great day to be working in agriculture. So thank you all for being here. Yeah. And it's beautiful to see all of the people that support agriculture. It takes producers, it takes input suppliers, it takes buyers, it takes everyone to make agriculture thrive. And really want to say thank you and hats off to you to supporting agriculture here directly in the Arkansas Valley. So another quote would share with you is the old African proverb that says, if you want to go fast, go alone, and if you want to go far, go together. With that, I want to acknowledge people that really made this automated weeder demo possible today. And if you guys, once I say some names for each of these sections, let's give them a round of applause afterwards. But the Arkansas Valley Research Center team, I want to thank Farm Manager Kevin Tanabe, Research Scientist J.B. Ma, and quasi-retired former research scientist Mike Bartolo. All these guys, give them a round of applause. Really were integral. I was the brainchild of this, residing up in Longmont, and obviously I could not get onions planted and broccoli planted and everything that was needed to make it possible. So this is put on in partnership with the leading produce trade association in Colorado, the Colorado Fruit and Vegetable Growers Association. And you would have seen this in promotional materials. You saw that in registration. I want to thank Marilyn Drake back there at registration. Give her a round of applause for making this possible too. And you also would have seen that this is made possible by a specialty crops block grant that's given to the Colorado Department of Agriculture by the USDA Ag Marketing Service. So I want to thank Tom Lepetsky and his crew from Colorado Department of Agriculture for making this possible. If you've tracked on this, you will know that we have both homegrown talent in this innovation space of agrobotics and talent that's really spanning the United States and across the globe. So I want to thank some of these folks today that you're going to see more of. Our homegrown company here based in La Junta and in Florence, Barn Owl Precision Agriculture, Sarah Hinckley and her team. The Carbon Robotics team based in Seattle, Washington. You guys can raise your hands. Carbon Robotics, thank you guys for being here. The Stout Ag Tech team based in the Salinas, California area. You guys raise your hands. Thank you so much for being here. And the Verdant team represented by Brad Abraham. Where's Brad? There he is. So you're going to see 3 demos today, one from Barn Owl, one from Stout, one from Carbon Robotics, and Verdant was unable to bring their demo machine out, but you're going to hear from Brad during the panel discussion immediately, kind of during and immediately after lunch. We had queued up another French company called Nio. They were unable to make it. They send their regrets. But I want to tell you a little bit more to kind of frame this in. And I'm going to tell you some things and you're going to say, yep, Adrian, we already know this. But this is the box that we're going to construct of knowledge and shared understanding that's going to send this thing forward. So it would come to no surprise to you likely that produce growers are dealing with ongoing recruitment, retention, and affordability issues in labor. If you look here at the poster, there's one sideway poster landscaped here in the front, one over there in the side. Colorado State University conducted a statewide labor survey in 2021. And one of the questions we asked various producers, and you'll see this thing filtered by produce growers, field crops, and livestock producers. But we asked them, if conditions don't improve for you with labor recruitment, retention, and affordability, what are you going to do? And can someone tell me, looking at that chart, what's the number one response from produce growers? What are they going to do in the face of ongoing labor challenges? It says they're going to mechanize more, right? Okay. So we saw that in 21 and thought, man, brilliant. I had already kind of tracked on some of this, but that gave us a real green light to think about. Growers are ready for this. They want to see it. We took mechanization to also mean automation and advanced technologies. I traveled to California last fall and went to a global ag robotics conference. And you'll see it on the other poster there by that column over there by Marvin. And it was the first time this happened in the United States. And it featured all these companies. And I got to meet the people from Carbon Robotics and Stout and NIO and Verdant. And I said, hey, would you want to come to Colorado and pitch this to growers and just let them explore and see if these are viable options? They said, yeah, let's do it. So that is the inception of this research, connection, and you heard the team that made it possible. We also know from more recent CSU research that on the affordability front, have you guys heard of this thing that happened a couple of years ago called Senate Bill 87? No. I know growers are probably like, oh gosh, Adrian's bringing this thing up again. The Agricultural Labor Rights and Responsibilities Act, right? So this is going to phase in overtime when it never occurred previously in Colorado. So in next year, you know that you're going to be faced with, in a 22-week period, any hours over 56 hours paying overtime, right? For produce growers who are highly seasonal employers. So what we found in recent research is that produce farms, their payroll ranges from 30 to just north of 50% of their operating cost. Real significant chunk. So what you're going to hear today and get into conversations about, and a lot of you growers are already thinking about this, is what is the return on investment for some of this machinery? And as payroll costs are inching upwards, that equation is probably going to change for you. So what else to share with you? CFEGA has a partner organization in California called Western Growers. Have you guys heard of it? Western Growers? So they're almost a 100-year-old trade association in California, and they did a survey with Colorado, Arizona, and California growers, and they determined that in 2022, growers in those three states, and obviously there's differences in types of growers in California and production systems compared to Colorado, but growers from 0 to 2,500 acres were spending $16,000 to upwards of $200,000 on mechanization and automation solutions. And they showed, I guess that was backwards looking, 2021. In 2022, they showed that 70% of growers had made investments in automation in one way or the other. And when they asked growers in the next 3 to 5 years, what are you going to do? 40% of them said they'll spend 10 to 15% more, and 30% of them said they'd spend 50% or more on automation solutions. So the future is here, folks. Before I go any further, I want to get a sense of the audience here, who you are. So could we start off with, if you're an ag professional like me, you're not a grower, you're not an input supplier, you're extension, education, government person, would you raise your hands? Let's see who you are. Ag professionals, wonderful. How about our input suppliers? People who are selling to producers. That would include our tech companies, input suppliers, our lenders, fertilizer, seed, all of those folks are input suppliers, great. And finally, growers, would you raise your hands? Fantastic. I think some of you are still preferring anonymity, and that's cool. I dig it. All right. So what else to share with you? CFEGA has produced 3 different labor conferences to focus on produce labor issues and solutions. Those have been based in the Arapahoe County area. And in 2023, we're going to bring it to Pueblo. So December the 14th at the Pueblo Convention Center, mark your calendars, we're going to be there talking about solutions to and highlighting current status of ag labor for produce growers in Colorado. Let's see. One of the most important things I can share with you is where the restrooms are. So the building, if you look through the pavilion, do you see the SUV and the trailer, white trailer parked over there? That white building, many of you know it as an extension office if you're local. Restrooms in there. There's also restrooms as we walk over, which we will in just a bit, over to where the demos are, in a building with a green roof. So please use that as you need. How many of you have ever made it to a Colorado Fruit and Vegetable Growers Association conference? A couple of you out there. You have been pleasantly annoyed with how much I press people to complete evaluations. We're all over-surveyed, but here's my pitch to you why this evaluation is important. And it's only 5 questions. It's super simple, super easy. One, the first reason, and Tom loves for me to say this, is that our grant award, Tom's shop has to report back to USDA what the outcomes were. Did you learn something new? Are you going to use what you learned? Those are the 2 questions we're going to ask you. Probably more important to you is the forward-looking question. We're going to ask you in the evaluation, what are the next steps that CSU and our partners should take to help advance mechanization and automation in Colorado? We want to hear from you. It's going to ask you to identify yourself. And for you anonymity lovers, it is absolutely anonymous. There's no way for us to know who you are. But it'll allow us to filter by growers, by ag tech companies we want you to complete it to. And because we think this is just the very beginning, the very start of this. So please, you're going to hear from me plead a couple of times. On the posters, how many of you in COVID got comfortable with QR codes? QR coded, loving it, right? Everybody loves another QR code. So those are on posters around the event. You're going to find them on slips of paper. That's the fastest way to complete the survey on your phone. All of you who prefer analog, everybody loves to use pen and paper. We got that version for you too. Just leave the survey with us before you leave. So those are the 2 things we want to highlight. All right, off to the races. What are we going to do next? This is the structure of the program and how it's going to flow for today. Scratch my face. We are going to walk over here in just a bit, and each of our tech companies are going to present to you. They're going to have 30 minutes. And tech companies, I'm going to start a timer for you and give you a 10-minute warning when we're at that place. So they'll start off, and we'll have the same PA system in the field so everybody can hear. They're going to start off and maybe offer you like a 5-minute intro of here's what the tech is, and then give a bulk of time to showing you what it is, the show and tell part of this, and then hopefully allow for about 10 minutes of limited Q&A in the field. We're going to get into a lot deeper Q&A right after lunch, about noon. We're going to serve lunch to you about 11:30. But we'll get into the deeper Q&A right in that lunch period. It'll be a panel of these guys, and we can. It'll be an AMA, an Ask Me Anything. We're gonna put it all out there. So, Barnell is going to go first. Stout is going to go next, and then Carbon Robotics, and then we'll from there give you more instructions. So, any questions, any thoughts before we walk over to the field? Cool. Nobody likes to speak publicly, but having the microphone's fun. I'd happily share it with you if you'd like to give it a try. So, great. So with that, who's part of our team there standing in the back? JB's got the hat on. So if you will walk to the field, and Mike back there in the 2, those guys are going to lead you over to the barn out area, and we're going to tow our speaker over. Some of our team could grab the speaker and the tripod. There's a gator if anyone needs. Yes. Restrooms and water.
So we got started in 2021 doing that, so we're still pretty young in that development process. We took the approach of a very small farm robot so that we could help small growers more. So our unit is designed to fit in 30-inch rows or larger. It is autonomous. It is designed to do different things. So what we are going to show you today is some of our cultivation tools over here on the left. We have weed whackers. They are not here yet, but they will be here soon. So if we can show you later, then we'll show you a little bit later. But yeah, small farm robots. So the company is myself, my brother, and my husband, and then quite a few of our team members came out to be here today as well. So we'll get started with this one on the left here. Captain? Can you help on that?
And folks, what may make sense if you can kind of stand on the sides where I am and on the other, if we make kind of a U shape around this demonstration area, you can get in closer.
So yeah, we have, in developing a small farm robot, they don't really make small farm implements either. So we've also had to work with our growers and say, hey, what do you guys think about making these small farm implements in order to work in these rows? And so luckily we've had really great support in the area from Hannigan, Hirikata, a bunch of other farmers.
Sarah, hold that thing real close on your chin.
Sorry.
Cool.
And so what we're looking at here is our robot. It's got weight on the front, but we are sweeping on the side. We have a rake in the middle. We are able to run on GPS. This unit is not running on GPS just because we haven't tested that much weight on it, to be very truthful with you. But the goal here is to clean up the side rows and then be able to kind of clean up the middle row as well. And then we also have units that come in and plant. So after this does its work, then we'll come in and we'll come afterwards and we'll plant in order to continue the kind of the work of it. It's hardware, and so we do have some issues in doing it. Like I mentioned, we're still pretty young in our development, so we are continuing to try to work some of our bugs out a little bit.
You guys feel free to walk in deeper into the field if you want to. You're not going to mess anything up.
Yeah. These are all weeds over here. If we're digging too deep. Yep, and so this is our robot. We will tire sometimes. Okay, well, while they're working on that one, we'll see if we can get this other one going over here. So what we have on this side of this is this robot is going to be towing this implement over here. You want to describe that one forward and backwards a little bit, Juki? So this is our slightly wider version. This one fits on the outside of the rows a little bit better. We are going to make a kind of more improved version of this upcoming season. But we can put this one behind that implement and kind of show you what the I guess the digging version of our implement is. And so the other kind of unique thing about us is that we do use the drone imagery to help support the ground-based analysis. And so our drone is able to capture the plants at a centimeter accurate level. It's also creating NDVI operations. And so in having that drone assist the robot, and then it also creates that NDVI so that growers can see the thermal and the other important aspects of their field.
I'm going to ask about what's the MBBI?
NDVI is just NDVI multispectral analysis. So we will, when the drone flies, you'll be able to see the crop health basically. So this one is towing our digging implement. It goes based on plant spacing, and it digs.
Does it go deeper?
It does go deeper. It is right now tuned for the broccoli, which grew very, very big in this area. And so we kind of have it, we have it on the top side right now, and it will go all the way through. We can go about an inch and a half.
Okay.
You need it?
Yeah. MS tools.
Up over there.
Where's the cameraman? I don't want to give him his red.
No.
Feel free to walk anywhere, just don't walk on the broccoli.
So one of the other unique things about our operation is that our robot, it can either go over the plants, it can go in between the plants and the spacing. And so we cultivate on the side rows as well as over the plants. This is not our only cultivation tool, so you can see on that other robot we have finger rakes, we have side sweeps, we have some other planting things. And so our approach is to be able to put whatever works best in that region on the robot and continue operating it.
So does it have a sensor that automatically knows the spacing between the plants? Is that why it's not chopping the plants?
That is correct, yes. So the question was, is there a sensor as to why we're not chopping the plants? And the answer is yes, there is a sensor. And so we take the combination of the drone imagery and that centimeter accurate spacing, and then we also upload that for our robot, and so they work together. We are not the, we have vision systems, but we are not the fanciest vision systems out there at this time. And so the plant growth for us, it can be a pretty big plant for our machines to be able to work. So we are able to go later season, early season, and continue on through before our robot starts to run over the plants is the goal for it. Yes, yeah, the question was, do we have varieties of robotic arms? And the answer is yes, we do. And so we can take off that one, and if we're not happy with that soil quality, like the San Luis Valley has a much rockier soil, and so this implement probably wouldn't work in that area. So we would take that arm off and put on a different arm in order to continue to operate and perform the mechanical controls is what we're going for.
So what's the time limit on the batteries?
The battery is a 8-hour for a single life cycle, and that is running a fully autonomous mission. It's going to decrease when I pull a bunch of weight, and so it probably would be 6 hours or so. But since we travel with multiple small robots, we are able to just expand our capacity as we continue to operate. So this one would be doing this task, but maybe a different area in that farm needed a different technique, then we would have another robot go out and do a different task for that section of the farm.
And how do you recharge?
We have the trailer. It's hooked up to charge our batteries and our robot. And then we have drone imagery as well that I don't think you'll be able to see on that tiny screen, but if you wanted to come and look at it, you'll be able to.
Cool. Thank you.
Yeah, of course.
Sarah, it may feel like you're loud in that microphone, but you really have to just kind of yell into it.
Okay.
Yeah, just
Sorry.
like it's a pipe, just yelling right into it.
I'm not good with mics. But yeah, if you wanted to come see this one more, you could. That's pretty much what it does though. It goes straight and it digs up some of the area of weeds. Our goal is to not harm the broccoli or the plant, whatever it might be. And we will continue to seek the support and advice from our local growers in order to develop different types of implements and different versions of mechanical weed control.
You may be at the radio frequency distance away from this receiver. And maybe what we're doing.
I did not practice this part.
You're doing great. Thank you. Yeah, you can stay out there, but no further.
Happy to take any more questions. I do believe that this one is up and running. So that's the kind of the other really good thing about our service approach is that we're not, it's hardware. We track robots in San Luis Valley, and in having the ability to have a team here from Rocky Ford and then a team in the San Luis Valley, we kind of understand the environment, the growers' needs a little bit more targeted. Modify it too in order to create the best holistic approach possible. And then again, that all includes drone imagery. So if you're multi Rocky Ford. So that one's just in Swink down the street. If you wanted to go take a look, we have. And then we have some small growers in Florence and San Luis Valley, and then Rocky Ford that are kind of working with us to continue to develop this approach for us.
Did you mention the
It's you're not putting any big risk on it. So if you have 10 acres, spending $300. If you have 1,000 acres, then it's going to be more. But if you only need us once or twice, we're only there once or twice. If you need us the whole season, we can add multiple robots in order to tune your to meet your needs all the time. And we don't have a farm size limit, so we can do things. Our plot in Swink is about a 1/4 acre or less, and then our largest plot in the San Luis Valley right now is about 150 acres. So we're very different in the range there, which I think is great just for the small grower.
other questions? Feel free to shout them out.
And it looks like that robot's coming back to us on that side.
Sarah, as an early stage business, what are some of your immediate plans in business growth?
Yeah, so like I mentioned, we just got started with this development process about 2 years ago. And we are looking forward to continuing to grow and design and develop the unit itself. We fundraise. We are seeking venture capital support. We have really great venture capital investors in Colorado who focus on rural and ag and kind of impact. So we'll grow our team, we'll grow our system, and we will continue to deploy the small farm robots wherever they're needed.
What would you say your average acre? I know it's kind of varies. What do you
Yeah, so the question was how many acres can we do in an hour? And so in the variety of our, we can send 2 robots or I can send 5 robots. So one robot can do 0.7 acres per hour. And if I need to send 20 robots, then that amount just expands. Or if I need to cut it, then it kind of reduces. So a little less than 120 a day at a 20 robot fleet.
When I was at the FIRA conference in California, there were university researchers that were developing some innovative platforms similar to what you're seeing Sarah come up with. Some of them little harvest tables that can move into the field. Worker put a harvest box on it. It goes back out of the field. So I mean, think about all the time you spend walking boxes in and out of the field. A robot could do that, right?
Yes, so we do have an additional implement. It's just around the corner, so we'll probably pull it out a little bit later. But it tows humans and it tows other things. We did, harvesting. I was sitting on the trailer harvesting onions, putting them into the robot and sending the robot back to the shop. So we'll be working on developing that towards the harvest time for this season as well. But the unit itself can tow 400 pounds, and then we multiply that by however many we have in the field, and that is the harvest approach. So if you wanted to keep your hand labor for certain things, then we could come in later in the season and supplement your harvesting and just make that job a little bit easier for your farm labor as well.
A lot of the technology that is making the headlines. Do you guys see the U.S. Today? U.S. News Today. USA Today. There it is. Stout was featured in there. There was one also, CNBC had a feature on some of this technology. Some of the media are grabbing the larger systems that are tooled to fit California farms and scale a bit better. We do have numerous small farms in Colorado and in California, but we're seeing a slower emergence of some of this technology. If NAO would have been able to make it today, they could tell you more about some of their smaller farm applications that have been perfected more so for farms in Europe that are often smaller. They're based in France, so. One of the things that we're excited about at CSU, and some of our College of Ag Science folk couldn't make it today, but Have you guys heard of this new thing? CSU can't be quiet about it. We talk about it all the time. But the Spur campus in Denver, we're just tooting our horn. We think this is the best thing since sliced bread. But one of the positions that was hired recently was a director of Ag Innovation and Partnerships. I had the privilege of serving on that search committee, and this person, Jordan Kraft, if you're from northern Colorado, you would know Kraft Dairy in northern Colorado, Morgan County. Jordan, MBA from Harvard, worked with a lot of ag tech companies, but is excited to work with folks like Sarah to help Colorado companies stand up and be more prominent as innovative solutions for producers in Colorado.
Yeah, absolutely. It's for us, it's great to be homegrown, I guess, from this area. We are, the resources, I would say, are sometimes limited in a smaller town, but being from rural Colorado and having family that grew up in La Junta and raised their kids in La Junta, that means a lot. And so our connection to growing the crops and to how important this job is to our farmers, I would say that's just as important as making sure that we have a successful business so that we can continue to provide great service. Colorado itself, and like I mentioned, CSU has been an incredible support partner for us. They let us come out here and run our robots and fly our drones, and again, they give us really great feedback on maybe you should consider this implement instead, or maybe you should try this approach instead. And we, as a team, our humans are very, very important. Our robots are important, but I would say our communities are even more important than that, because it just doesn't work without that support. And we have a lot of growth to do, and we're really looking forward to continuing to try to do that.
Fantastic. What other questions you guys have for Barnell Precision Agriculture, Sarah and her team? What's popping up for you? Hard questions you want to ask. How did you get started, Sarah? Why did you want to do this work?
Yeah. So our grandparents in La Junta, they started to get sick. And so when we moved back out here to be a little closer to them, our companies would not keep us. They wouldn't let us work from rural Colorado or from La Junta. My brother was doing the drone technology at the time, and so we got started just by connecting with our neighbors and showing up and saying, hey, what do you think of this technology? How can we help? And since then, the continued question has been, how can we help? What do you guys need? And that has been our driving factor the entire time. The challenges for creating a robot are they never stop. They will never stop. The hardware continues to present its own challenges, but this season we've seen different weather here in this area than we've seen in a very long time, and so the crops grow faster, and they need we have grown broccoli really, really well here, which doesn't happen often, and so we originally just got started to figure out how we could help, because we are very, very connected to our communities. This is my brother Jaron, by the way.
Hello, my name's Jaron. I just wanted to give a shout out to Chuck Hannigan over there. When we first started 4 or 5 years ago, Chuck and his brother Eric, they were the first ones to even talk to us. They thought I was crazy. They still do, but I just want to say that I'm very, very grateful to Hannigan Farms and CSU. Mike Bartolo has just been fantastic, and so yeah, that's all I got to say.
We got one question here and then one over there.
Can they tell us a little bit more about the drone service? I know this is about the robotics, but what they
Yeah.
do with the drones?
Yeah, so the drones are incorporated in the entire service no matter what. So we use them as our foundation. If you want the imagery, we give it to you. It is NDVI and it's RTK precise, so this map could feed into your current tractors, your current spray systems, and it can tell you prescription applications. We are not agronomists, however, so you have to decide what you want to put in it. But we can give you the exact point of your plant, and I'll pull it up there in a minute on our way back over. But we are able to see the exact location of each plant, the exact boundaries of each plant with that imagery. And in doing that, you can, say I want a specific amount of nitrogen or phosphorus or something on this area. It also detects potential irrigation problems. So if you have a leak and your team is out, fixing a tractor somewhere else, then that drone imagery can say, hey, you have a leak over here. You should probably run over there and fix that, and then, whatever decision you make about that. It is not an added charge for that. So if we are out here at your farm, we're going to give you that imagery if you want it. If you don't want it, then we have it as a backup until you do want it.
Question here.
Good morning. My name is Mark. Thanks for being here. And I had a question about most of your devices are battery powered. Could you talk about your decision to make battery powered versus internal combustion engines?
Yeah, so the biggest thing is to, just be able to continuously charge. So we like to have the opportunity to charge while we're in transport to the next farm. And then battery technology is going to continue to become smaller, less inexpensive, and a little bit on the regenerative side. I know, where the batteries come from are not necessarily part of that story. But in being able to have the regenerative and the sustainability of the system, but the system is actually lightweight enough, and having a small battery, that we do qualify for soil health credits too. So we are virtually no compaction, and in that we can also plant and harvest cover crops. And so that combination of the battery and then the other aspect is kind of how we started the building, the design approach for it. Yeah.
And the batteries can be hot swapped in the field.
Yeah. So we killed one for the first time yesterday. So, in 8 hours.
On purpose, you killed it?
Yeah, kind of.
Yeah.
And so we just took it out, and it's back at the shop now, and put a new one in. So they're light enough. They're 50 pounds each. We bring a backup for each robot, and that just gives the robots the ability to just go. They can work at night as well, and then in having the ability to work at night, then we can avoid the really high heat because it is still hardware, and it still doesn't like 110-degree weather, but who does? And so we, in having the system that we have built, we can work at night, we can work in the winter, if we want to do, winter cover or other things.
Great. Marilyn.
Maybe I just missed this, but you charge a certain amount for weeding per acre. Now, does that mean you bring all the equipment necessary to do that? So it might be both of the machines we saw today. Is that how that works?
Yeah. And so we do have the weed whacker around here, and I'll get that set up and we can show it after. But we will, in any kind of weed control, we can do the precision, we can do the cultivation, and we can do the whacking. And that is all the same price. As we we're designing a soil sampler, so in that instance, we would add $1 or $2 to that weeding, and you would get soil samples from every region on your farm rather than you having to go out and do it if that's something that you like to do. And then for the harvest support, for pulling the humans behind, again, it's just a slight price difference. And the only reason for the price difference is because the robot needs to go a little bit slower so that the humans have time to pull the crops, dig them up and pull them, put them in the bucket. So we adjust based on speed or based on farm needs.
Sarah, we got a couple more minutes. Anything you else want to say or do?
I think not at this time. We'll get some more robots and we'll be around. Again, if you want to come by to the swing plot and kind of see how that is fully planted by robots, fully managed by robots. No nutrients on that field at this time. We thank Chuck and Eric for the water and the support in that field, because that is part of their trial plot. And yeah, we're around. If you have any questions, just let us know. We're looking forward to continuing to grow and develop for you.
Wonderful. Help me thank Sarah and Barnow Precision Ag. Fantastic. So we are going to shift.
Hello? It's on? Good morning, everybody. We're going to move the tractor and implement our machine a little bit further in so we have better visibility on it. So yeah, my name is
going to have to come in close because we're going to talk over the noise of the tractor. And you're going to want to...
We'll have it off right now, Adrian.
Okay, we'll have it off. Okay.
We'll just kind of go over some stuff.
Perfect. Once we get going, you may want to be on either side of it so you can see it moving and walk with it. You can see the whole operation.
Okay, guys, good morning. My name is Sal Espinoza, Director of Operations over at Stout Industrial Technology. With us today is we have Antonio, who's one of our service techs, and Steven Snyder, who is over there with his hand up. He's a co-founder and basically lead electrical engineer, software engineer for our equipment here. So Stout, a little bit of history behind Stout.
So I'll put that right up close to your mouth right
Oh,
here.
sorry.
Yep.
There we go. So Stout, the history on Stout is Stout was actually developed within a large grower shipper out of Salinas, California. They farm about 50,000 acres worth of vegetable crop, vertically integrated company. So the way that Stout was born was that they, just like everybody else, had a lot of issues with labor, and anything that was mechanical that was out for them to use was not sufficient to cover enough of their ground with uptime, just speed, and overall reliability. And so Stout, the way it was basically born, was it was intended to be sort of an internal department within that company. But as it progressed and the machine was built and everything worked really well, they determined that through conversation with other local growers who basically said, if you guys actually build this and it works, we'll buy some off of you. And so that's how Stout was born. We have machines all throughout the states. We have machines in California, Arizona, Florida, Texas. We have 2 going down to Mexico. We have 1 about to ship to Australia any minute now, and 3 in the UK as well. Our machine, the way it works is it's obviously connected to the tractor, 3-point hitch attachment with the PTO pump. There are no electronic lines or hydraulic lines connected to the tractor other than the PTO pump and 3-point hitch. Once the RPM is running at 1,000 RPM, the machine is basically what we call self-contained. So it contains its own hydraulic oil, and once it's pushing out the 1,000 RPM, that spins the alternator, which keeps the battery charged, which keeps all the electronics charged or working. As you can see here, these are cameras here enclosed, and these are the lights. The machine is IP67 rated, so you can pressure wash the entire machine without any issues. It works all day and all night. Currently, we have a few of our customer base actually runs 2 shifts.
So I'll speak a little bit louder and keep that mic near your mouth. I'm sorry, I'm over here to your side. You can't see me.
Okay. So we have a few of our customers actually run two separate shifts with the machine, so they run all day and all night. And we have remote access into every single machine, so we can troubleshoot machines, we can see what's going on, and we push updates to the machine just like you would your cell phone or computer or whatever. Currently, the machine works in about 30 different commodities. And again, any new commodity that we need to train on or teach, we grab the imagery from that field, we upload it, and we train on it. And once it's ready to go, then we push it through to the machine, and all machines get that same update. It's not for one machine. As of December of 2022, New Holland is a minority owner in Stout. So through the partnership, we have dealer support all throughout the country and the world. So anything local would go through your local New Holland dealer, and they will provide service and support. So, as you can see, the machine is built to last. It's a pretty robust and rugged machine. Our early machines have about 6,500 hours on them already and are still running. We've developed a really strong service and support program. We have user guides and videos and everything you would need that a typical operation or grower would need. The key here is that, again, the machine was designed by a farming operation, and so the way the machine is built, it's built sort of foolproof in a sense, where anybody can really work on it and most people can use it. The machine has, on the side here, it has a screen, an HMI screen, which is basically the control panel. So the way that it works is you set up on the screen your tolerance levels. right? So how far or how close do you want these to open to the plants? How aggressive you want to be as far as depth, right? So you can move this guy up and down. On these wheels here, there's an angle sensor, and we'll turn the machine on right now so you guys can see. Excuse me. There's an angle sensor that allows it to basically travel with the bed top. So you're never going to struggle with your blades too far into the ground or too shallow, right? It depends on you and how you want to set that through just moving the actuators on the Z table. Again, it's mechanical actuation, so these guys open and close around the plant. And again, the cameras are here, and the lights are there, flanked on the sides. Yeah, we met Adrian last year at FIRA, and he had asked us if we wanted to come out to something like this, and we basically said, yeah, we'd love to participate, so long as we get to demonstrate machines and actually run in the field, because it's one thing to see stuff on video, on the computer, but to actually see it, feel it, you know, poke holes, whatever you guys want to do, it's here, and you guys can actually look at it and see it running and working. With that being said, I'd like to thank Adrian and everybody that put this on. I know it's not easy. It's extremely difficult, the timing and everything. So Adrian and his team, I think, did a really good job, and we're really appreciative of that.
Saul is overly kind. This was obviously my first rodeo. You guys, I'm going to out myself on this, but we did not quite get the timing perfect. So I'm going to explain a bit to you, because we didn't give them the best conditions for demo, but you're going to get the concept of it. So we transplanted broccoli mid-May, thinking that it would be a normal year. It'd be really hot. Broccoli would be stressed for a while, wouldn't grow so fast. But you know what happened in Colorado this year? It was like perfect broccoli growing conditions. And the broccoli got real big. And I got down here to the Arkansas Valley Monday. I sent Saul a picture. I said, hey, Saul, what do you think about the size of this broccoli? He said, wow, that's some big broccoli. So some of their tolerances, we got the broccoli a little bit too big. So we went in there. You're going to walk past it. You're going to say, what's wrong with this broccoli? We went in there and we took a hedge trimmer and had to prune it back to get it within some of the tolerances of the crop. So all apologies to Stout and Saul. We tried, and there's not a ton of weed in there either. So, but you're going to get the concept of how this works.
And that's perfectly fine, because again, in a real world application, that kind of stuff happens, right? And so it's never going to be perfect. That being said, some of our growers actually run the machine up to 3 times in the same block. So about 2 weeks after wet date, another 2 weeks after that, and about 2 to 3 weeks before harvest, they'll run it again. The machine, again, attached to the tractor, can go about 1.5 miles. It'll do about 1 acre an hour. This is one size of the machine. So this machine is actually modular, in that you can, right now it's set up on 80s, 2 40-inch beds, but this machine can extend out to 84s. It can go down to 60s. You can remove a backbone, you can remove an actuator. So right now, as you see it, we're going to run it in what's considered 2-line 40s, right? But this whole machine, the way it's set up, can be a 6-line 80. This machine can actually go up to 8 lines as well. And we have bigger machines that can cover 4 beds, 4-bed 40s, and cover 2-bed 80s. And we're currently working on a 3-bed 80 that will be able to fold as well. Obviously, that's going to be a much bigger machine. But again, it'll work about 1.5 miles an hour. It'll do about 1 acre an hour, maybe a little bit more, a little bit less, depending on how your tolerance is, your field conditions, and basically the way that you want to run it. We are also working on a data platform. The data platform is currently in testing mode right now, and that will give you basically field analytics, plant size, plant health, expected harvest date, along with uptime and downtime on the machine, right? How many hours has it been running? When was it shut off? Average speed. So that's all in the works. It's actually, we have it now. It works, but before we release anything, we like to really test it. And so with that, the first machine that was ever built, the prototype, got about 1,000 hours on it prior to actually going into production mode. Again, and this is not a prototype. This is a fully production ready machine. We have, I don't know, over 50 machines out and about. So yeah, we'll turn it on. Again, it is the tractor, so it might be a little bit noisy, but we'll turn it on and we'll kind of just run some things on it so you guys can see what it looks like, and then we'll run it through the field.
How many different crops can you
It does about 30 crops right now.
You can do like a close onions and stuff.
So anything really tight like that, it's a good question. We need about 4.5 inches for mechanical actualization in between plants, right? What it can do is it can side shift. So if you want to cultivate and put these guys really tight up to that plant, and basically you can disable this from opening and closing on the screen, then you can cultivate because it'll follow the plant line. So these actually move 3 inches. They have travel 3 inches left and right. So it works in both direct seed, transplant. It works in most anything that's planted, as long as there's some consistency, right? There's obviously, it's not a miracle worker. It's not going to do everything, but yeah. Let's go ahead and turn it on.
When they start moving with this, a really cool experience you may want to try, and please avoid walking on the onions over there on the other side. There's a little space you can walk, but you may want to walk alongside this thing, touch what it's doing in the soil, feel it, because it's going to take a pass all the way to the end of the field. So be prepared to walk. That's the cool part. Get your cameras out if you want.
One of the cool things about it too is it's called the Smart Cultivator.
So at this point, you're going to have to yell into it so they can hear you.
Okay. So again, one of the cool things is that the machine is called the Smart Cultivator because it has traditional cultivating tools, right? You have your furrow shovels here. You have your sweeps that go in between the plant rows, and then obviously you have the hose, basically the knives, that will fully cultivate your field. So along with removing the weeds, it's actually doing the cultivation job as well. And some of our growers have developed their program where they run this as the actual cultivator.
Keep that mic close to your mouth and yell in it. They can't hear you if you don't. Sorry.
Huge help. It typically takes about 3 to 5 minutes to load up, and what it's doing right now is all the computers and all the lights are turning on. So all the software is basically loading onto the machine. Once we get it going, again, I'll show you guys sort of how the mechanics work, and then we'll just run it through the field.
Is it possible to lower the RPM?
No. And again, we have remote access to every machine, so we can actually push updates through, or again, troubleshoot machines through our remote access. So as you see there, now it says ready. So you press start. Now everything is activated, right? So we'll go ahead and lower these guys here. Cool features as well as you're running through the bed, those are now on the ground. As you exit the bed and lift up the implement, those automatically lift up off of the ground. Go ahead and lift the implement. Okay, lift it higher. Well. So they lift, and once it's back on the ground, they automatically lower and recenter themselves. So the actuation portion of it, that's how they work. They open and close around the plant. Again, one of the neat things about it is on the wheels, on the stainless steel wheels that you see there, they have angle sensors. So as the terrain changes, that keeps about 5 pounds of down pressure on the bed top, allowing you to basically set your blade depth with the Z table, and it'll never change on you. So you see this. So as this pivots, this will automatically float with your bed top or your flat ground. All right, let's go ahead and just throw it in there.
Okay, you guys ready to walk? Come on into the field. So again, be careful with the onions over there. Don't walk over them, but come on and walk along with the machine. You can see, get in close.
You can see, hold on, this is not working the way it's supposed to.
So if you ever have broccoli in your field as a weed, this is what that looks like. It was working beautifully yesterday, so. If we are unable to get this the way we want it to be, you can always go online and see videos of how this thing would work under optimal plant height conditions. Ideally, we would have transplanted that broccoli first part of June. It had been about 3, 4, 5 true leaves.
So yeah, it's a tough field, but you can sort of see again how everything's supposed to work. It opens around the plant, closes. It's just the broccoli is a little bit big, so. You can see how it opens and closes around the crop. Go a mile. Go a mile. Go a little bit faster. As you can see, the machine is side shifting to accommodate where the plant is. What makes this a little bit difficult again is the broccoli is a little tall. Let him stop. What's that? Yeah, so what's going on is the broccoli is a little bit tall. So our tolerances as far as height was about 10 inches, 9 inches. So this is pretty much right around max. So if you noticed, it wasn't so much, it wasn't closing on it. What it was is this was actually kind of grabbing along the arms on the sides. That's really what the issue was there. Again, demos are a little bit challenging in timing and setting everything up. That being said, you know, we're very confident in the machine and what it's capable of doing. We have, again, over 50 out and about, and it works perfectly well in broccoli. But again, with this type of equipment, there's a timing aspect to it. There's being able to set up your program for it, right? So what the grower's program is. And so this is just a challenging field, but it's okay. I mean, ask any question that you want to ask. Obviously, it didn't perform as well as we had liked it to perform. As we can see, we're harvesting here. Yeah.
In a scenario like this, what sort of adjustment would you like to make to the machine?
So that's a good question. So there are several adjustments we could make. Now, obviously, in front of a big crowd like this, you don't want to be doing everything, but we could adjust the side shift a little bit to be a little more aggressive. So if you guys noticed, it was moving left to right a little bit, trying to find that plant center. So I could adjust that speed to go a little bit faster, so it doesn't take as much time to side shift and find where that center is. So I could set that speed to go faster, and then from there you would mechanically just move your actuators to match the plant spacing. The difficulty here, and this is, again, it's tough, is you start out with some that are about 12 inches row to row, and then they kind of expand to 13 and 14, and so it kind of does like a little bit of a balloon shape on you. So that's the difficulty here with demos. But
I saw you were telling me in your image library you actually have images to be able to do this with peppers, right?
Yes. Okay. Yeah. So it works perfectly well in peppers, and I have the videos here on my phone. It works in about 30 commodities. You know, I'd say most of our growers primarily use them in lettuces and brassicas, but it works in, we are actually actively working on the tomato model. The tomato model is almost there, it's almost ready. The pepper model works very well. Broccolis, cauliflower, cabbage, it works perfectly well in all those commodities. Unique spacings as well. The machine going to Australia actually only has 2 actuators on it. The machine in Texas only has 4 actuators on it. So there are ways to make this work for your field specifications and what you grow.
Many growers in the area are on wheelbase of 60-inch centers, and you can accommodate that too, right?
Yeah, absolutely. We can accommodate. So again, this one single machine can be, right now it's set up on 80s, but it can be 84s. It can be brought down to 60s. You would obviously need to remove some parts on it, some components on it, but again, everything it's not extremely difficult to do. It's been developed and designed in a way where everybody that farms can use it. So from your best guy to your worst guy, right?
And you told me that in California there are some machines that have been running. They have 6,500 hours on them.
Yeah, so the early machines were delivered in May of 2020, and they are up to about 6,500 hours already. Actually, past that now. So they were delivered in Salinas, and they went down to Yuma, came back to Salinas, back to Yuma, back to Salinas. So this year they're going to go back down to Yuma. It would be their fourth time in Salinas, fourth season in Salinas. And obviously with machines that have that many hours on them, there's different wear points, different maintenance, preventative maintenance challenges, I guess you would say. And again, through all that, through having machines in the field, we've identified all of those issues. We've identified how to relegate the issues and how to fix them quickly, which I think is a super important thing with this technology, because there's the fact that it has computers, cables, cameras, lights. It's hard to sort of conceptualize, and it's hard to say that this is a farm piece of equipment, but it is. And the whole point is for you to use it and abuse it, because it's in the ground all the time. It's never going to be perfect or pretty or pristine, but our machine is built the way it's built for that reason. As you can see, it's anodized, so you can pressure wash the entire thing, prevents rust, no issues with that. You can run it early morning, you can run it late at night. And again, all it takes is the one operator, right? The one operator, every once in a while, he has to go to the bathroom, takes his breaks, talks to his wives and mistresses on the phone, and just keeps going. But yeah, the machine itself is, again, apologies for the difficulties today, but it works perfectly well.
My apologies to you. You guys traveled. Sal was in Australia recently, and he was just getting over jet lag coming in here and setting up. We had to correct this broccoli issue, and so that's on me. So
that's okay. No worries. And one thing I want to note too is actually this machine actually does belong to Case New Holland. It's basically their roadshow, one of their roadshow machines. So this machine this particular machine has been in Salinas, it's been in Yuma, it's been in New Jersey, it was just in Washington, and now it's here. And so we've had to configure it to every single different type of region, we all thought in Salinas that everybody grew the same spacing, same everything, but it's not the same all over the world, all over the country. Everybody has different dimensions for different reasons. So that's one of the cool aspects of the machine, is the fact that you can, in fact, change it, manipulate it to your spacing conditions and what you like.
Questions for Saul before we go over to Carbon Robotics over here to Patrick.
How does it do in rocks?
It does well in rock. So if we take a look at, if we open up the hood, on the actuators are our shock absorbers on there. So what that does is that keeps that down pressure, and as the rocks hit, it'll fluctuate with it, so it won't just spring up or break or anything like that. And those are just simple shocks that you can buy from us, or you can get off the shelf at Fastenal or whatever. That's one key thing is we try to make the components on the machine fairly easy to buy if you needed to. If you didn't buy it direct from us, you can pretty much go on the shelf, store shelf.
Why is the screen on the machine instead of in the cab, so there's no way to adjust or monitor from the cab?
It's a really good question. And the answer to that is there will be a screen in the cab. We are working on that right now. It's just going to be a Bluetooth screen that's going to match exactly what's on the screen on the side of the machine. But to further answer that question is once you set the machine up and you set your tolerances, you pretty much don't need to mess with it after that. Now it will take the operator looking back every once in a while. As you can see, we don't have cameras on there, reverse cameras. Growers have added their own camera system to it. I mean, they're $100 on Amazon. It's just way easier, and you just plug them into the cigarette lighter or whatever it is now, USB port, and it works perfectly well. But we are working on it. It's testing right now, and it works perfectly fine. We just got to push it through.
Any other questions? We got time for one more.
Has anybody asked the weight of the implement itself?
Nobody's asked the weight, but I'll give it to you. The weight of that implement is about 3,600 pounds. So you need a tractor, preferably New Holland. Doesn't matter. It's color neutral. It'll work on any on any type of tractor, but we prefer blue. 1,000 RPM on the PTO, and typically about 100 horsepower on the tractor. And that's simply because of the weight and because of how far it extends out from the 3-point hitch. But it doesn't have to be a nice pretty cab. It can be an open cab. Good luck finding someone that wants to be in an open cab. But yeah, that's the weight of the machine.
Help me thank Saul.
Thank you,
And
guys.
all the team from Stout that's here today. We've got a couple of them, I think 3 in the crowd.
Yeah, feel free to ask any of us questions. Myself, Steven, again, he's our coach.
Also give a chance to share your Q&A over there. Carter, he is a sales rep with Carbon Robotics. Austin, over to you.
Adrian, thank you. Thank you CFVGA and CSU Extension for giving us an opportunity to be out here. I'm Austin Carter, I work for Carbon Robotics. I'm here with Roy and Travis, and we are the laser weeder. So the implement I have behind you is our demonstration bud. It's not a commercially available product, but we use it in instances like this to showcase the technology, let you see what we can do. The company was started in 2018, headquartered in Seattle, Washington. At the end of this week, we will have 35 units in 17 states and 3 Canadian provinces. So that's a little backstory. We use AI and deep learning technology to move over 40 plus different crops. There's 4 predict cameras in the front. On this unit, there's 8 target cameras. Those predict cameras work with our deep learning technology to identify the difference between a weed and a crop, and use lasers to shoot that weed with sub-millimeter accuracy. So what I want to do here is just give a little introduction to our company. We're going to get the machine going, let it run to the end of the row. I'll answer questions if you guys have any, but then bring it back and answer any more questions you may have. Sound good?
This is your cool video opportunity also. You want to walk alongside it. Look, you can see the spark underneath the machine. That's where the laser tracking is.
Guys, if you can, please just come up to the machine, in and out. Don't ask, just plug this in.
Big thing is, we have something fast. Why don't you weed over here where the weeds are bigger? The reason we don't want to weed, we have to change the mentality of weeding. We want to weed when the weeds are small. We want to weed as soon as the onions, if you will, are coming up out of the ground. So we want to weed 10 to 14 days after planting. That way, there's less time shooting that weed, and we can move faster through the field. We can cover more acres. Now,
Can you use the mic? Put the mic really close in.
It'll be. I don't have a mic. I just have a really loud voice, my wife says.
We can't hear you way over here over the noise of it.
I was just saying that we had a couple people ask, why aren't we weeding over here where the weeds are bigger? Because we don't want the weeds to get that big in our fields. Okay, plain and simple. It's taking moisture, it's taking nutrients out away from our onions in this case. So we want to weed 10 to 14 days after planting. For instance, the onions are coming up, weeds are coming up. Therefore, we want to be in there weeding as soon as possible. You say, well, the weeds aren't going to be there. Believe me, the weeds are there. If the onions are growing, if they've germinated and onions are growing, guess what? You have weeds coming right there next to them. And the model, I come from Central Washington, Washington State. World's largest onion grower is there, 90,000 acres. They have 4 of our machines. The machines, see the flags down there? That's how wide the machine is. 20 feet wide. It will take in 3 of these beds. They are running it. They go through the first pass, getting 90 to 95% of the weeds that are there. That first pass takes in the annual weed growth for that field. We'll get about 60% of the annual growth that first time the weeds are growing. That's what they're seeing. The second time through the field, they are going to be getting into the high 80s of the annual weed growth for that field. If they have to go through the third time, they will be 95 to 99% of the annual weed growth. That's their weeding model right now. Another very powerful thing is, you see this hard crust on top? If that is not disturbed and you have a rain storm come through, chances are smaller that you're going to get any second emergence of any weed because of that hard crust that's on top. We all know that it's cheap to go through and cultivate. $10 an acre. You can go through and cultivate multiple times, but you can't get close, and you're disturbing the ground, and guess what's going to happen? You're going to get regrowth once you put moisture on it. With the laser weeder, we create this hard pan, we keep that, and that helps deter the growth of the weeds. Very powerful step with the laser weeder, getting what is growing initially and getting any second and third emergence, along with not disturbing the ground. The question is, so our big machine, our actual machine, how many acres are we getting a day? The machine is 20 feet wide. Once again, it's as wide as those flags down there. They're running at 24 hours a day. This onion producer that I was speaking about earlier, out of that 24 hours, they are actually shooting weeds 20 hours a day because of rotation, breaks for the operator, so on and so forth. Out of that 20 hours, it's about 40 acres to 45 acres depending for one machine. And the reason that is, sometimes your weed density is higher, therefore you have to slow down. Sometimes it's not as heavy, so it can speed up. Average is between 1 and 1.8 or 2 miles per hour is what it does through the field. The actual implement sits behind a tractor, John Deere if you will, is a 6175. It has a front end PTO. Out the front of the tractor, you have a generator that runs off that front PTO with a pigtail that goes back to the actual implement.
What kind of generator is this?
This one, the generator, this autonomous one for demo purposes, it has a 4-liter Cummins diesel in it that's running it, and it has a generator off the side that powers the lasers. There's a cooling unit in there for the CPUs, a cooling unit in there for the chiller, and so that's what the generator's there for, to supply this autonomous vehicle.
In the Columbia Basin, did they eliminate cultivation?
The question is, in the Columbia Basin, did they eliminate cultivation? Yes. Because you will see how close it gets. It can shoot within millimeters of the onion. And onion is one of our most powerful models right now, because as the machine goes through, it's collecting data. It is a true AI, and it is sending that data to the headquarters. The programmers are seeing what's going on, saying, oh, I missed that weed. Why did I miss that weed? Is that a weed or is that an onion? I'm not sure. And a situation with that is when onions pre-emerge, if we have any onion growers here, you know onions just don't pop out straight. They come out and have a hook sometimes, and that tip hooks in the dirt. it was shooting that thinking it was grass or a different weed because it didn't have the characteristic of that straight onion leaf. So guess what? This is, I don't understand this terminology, but this is what the deep learning programmer said. They punished the program. I don't know how you punish a program, but they punished the program and it stopped shooting that onion that had that characteristic of that curl. For instance, 2 weeks ago, I went into, up in Eastern Washington, I went into a seed company that had Indian blanket flower. Never heard of it, never seen it. Machine never seen it. We pulled in 2 days before the demo. We took imaging every 2 feet, sent that off. They label what that plant is. They label the weeds. They download it. I started the field as I was coming through. It started at high 40% accuracy. About 100 feet in, it was at 60-some% accuracy. By the time I did the demo, it was in the low 90s. That's how accurate it became. The question is, does the machine learn as it goes, or is it the programmers? Yes, the machine can't learn by itself without the programmers telling the machine what to do. Yep.
Example right here. It's hard to get closer than that one was.
Yep. See, this gentleman just pointed out how close it got. That's, we can get in, shoot the weed, and not damage the onion. You can't cultivate that close.
Why don't you program it to kill anything that's not an onion?
The question is, why do we program, or why don't we program to shoot everything besides the onion and kill everything? That's the goal. Sometimes, another thing, how it was put to me by one of the programmers, we have cameras at the bottom of the laser weeder, and it is seeing the weeds in what I call, and this is not the terminology that he told me, I just call it this, in this kill box. And as these weeds are entering, it is saying, yes, that's a weed, oh, that's an onion, oh, I don't know what that is. There's those choices. And then from there, it starts to prioritize what weeds it is going to shoot. So we are trying to get to 100%. That's our goal. But we're about 95% to 97% usually on our production, because sometimes that weed density is too high to shoot everything that's in it. So it's prioritizing. If you have 10 little weeds and 2 bigger weeds, guess what it's going to do? It's going to shoot those 10 little weeds, leave the 2 big weeds, so the next time that you come through in a week or 2 with the laser, it can have more time to shoot those 2 bigger weeds and kill them, instead of shooting those 2 bigger weeds and leaving 4 or 5 of the bigger ones or the smaller ones, and in 2 weeks they will be bigger weeds, and it won't shoot all of those. So it's prioritizing as it's going to be most efficient.
When's the weed too large to kill?
And the weeds, there are, what is a weed?
When's the weed too big to
When
kill?
is a weed too large to kill?
We got big weeds around here like this.
Well, won't kill that one, and I won't even try pulling that out because it's going to hurt my back, so I won't even try that one. So the laser will kill any weed, okay? I like looking at things at extremes. If you set the laser on that weed all day long, I will kill that weed that's 2 inches in diameter, but I won't kill any other weeds in the field. What we want to do is, once again, back to that first question, why aren't we weeding over here? Why are you weeding here? Because the weeds are smaller, shorter duration, and we can keep our ground speed so we can cover and weed most efficiently.
Does it not slow down as it goes because it's bigger weeds?
Great question. Does it slow down because they're bigger weeds or more weeds? Yes, it does. For instance, another onion field had a drip system in it. There was a hole in the drip system and it was spraying out, and there was about a 15-foot diameter that there was a really large flush of weeds in it, because the water was from the surface down and instead of from the bottom up towards the root. So as we were going, and this was behind the actual large production laser weeder, sorry. As it came in, it says that, hey, we have more weeds here, we need to slow down. It indicated to the operator, we need to slow down. It slowed down. It weeded through that section that had that drip system leak. As soon as it went out, it said speed up, and away we went, sped back up.
How many acres one machine do if it was just onions?
The question is, how many acres will a machine do if it's just onions?
It's going to come back with the same acres again and again.
So once again, in a 24-hour period, it's running about 20 hours, and we're seeing about 40 to 45 acres in that 20-hour actual shoot time.
But in a season,
Oh, in a season?
in one onion cycle, how many acres could one machine cover?
I cannot. It all depends on the weed density, and every region's different. So 40 hours.
The Columbia Basin, 4 machines for how many?
They've been running them ever since the 1st of March, every day. So yeah, so 40 hours a day times 180 days. 40 acres a day, because they go from one field to the next, to the next, to the next. And what they're seeing is, this kind of leads into another scenario. When you have this machine and you want to hit that window of weeding 10 to 14 days, you have to schedule your planting. You don't want to plant 500 acres in 1 week, because then your laser weeder won't be there if you only have one machine. You want to be able to plant and keep up with your laser weeder depending on how much you can laser weeder per day. Therefore, if you only have one machine, you plant 40 to 45 acres a day. When do we come back for the second go around? Whenever they see that second flush, if they get a second flush. Because drip tape fields are different than irrigated from the top, from circles or whatever. Whenever they see that, and it's just up to the farmer, whatever they see. But you do not want to let the weeds get big. No, the question is it only surface or is there root control? We do not shoot the roots. As soon as the plant hits photosynthesis and we're able to hit that stem, it explodes the moisture in that stem, and then it cauterizes it, so it will not grow. So actually, you are killing the plant, because at that point, that root can't regenerate and go back into photosynthesis. Soil moisture does not affect.
So, like carrots, can you go in and weed before they come up?
Question is, as in carrots, can you go in and weed before they come up? Yes, but if you're going to disturb the ground, it's all up to the farmer. But it won't do any harm to go in and weed ahead of planting. If you have transplants, like if you have a crop that you come in and do transplants in, yes, you could weed before you do the transplants, because you're not disturbing the ground when you're doing the transplants, when you're making those holes. So that would be a scenario there.